In this video, I'm going to take just a little bit of time and talk about the tone generator on the 65265. And maybe to start out here, I will turn on my system, and I now have it set up so that when I turn it on at the beginning of the power on sequence, it does a quick little beep sequence using this little piezoelectric speaker. And I'll maybe zoom in here. And then at the end of the power on, kind of right before it jumps into my main loop, I have it to then play another sequence followed by a couple of additional sequences. And I'll turn it on and let you listen to this. Now I'm using a headset as I record this, so I'm going to use an additional microphone that I'm just going to set by that piezoelectric. Oh, let's see if I can do this in a way that this will just sit here. But something like that. So that's just a little microphone that I will record that audio, because my main headset's not going to pick that up, and my main headset is also doing some noise removal, which pretty much takes out any post-on beeps that might come up here. So I'm going to go ahead and flip the system on. And I'm going to reset it one more time just to get I'll get this initial beep captured. So I'm going to hit reset and stop talking. Okay, so hopefully that audio is picked up here with that microphone. But what I thought I would do is talk through what does it take to make that work. And the first thing I'm going to do is jump over here to my computer and pull up the schematic. And when I look at the schematic here, what I want to look at is how do I have this little speaker hooked up. And I'll point out on the microcontroller, there are two pins 94 and 95, that are labeled TG0 and TG1. That's a tone generator, kind of tone generator 0 and tone generator 1. And I'm only using tone generator 0, so ignore the 1. I'm not doing anything with it right now. But what I've done to connect to that is this little circuit. So pretty simple. This buzzer is that piezoelectric speaker that I have mounted on the PCB. And I have the TG0 signal going through a 4.7K resistor into this little transistor, just a 2N3904. And I have a 1K resistor in parallel to that piezoelectric. So very simple. I think some people will just directly connect the tone generator to the speaker. Others might go through some other way of amplifying. For me, the audio level is about perfect on the board for when you're standing in front of it or using it. Maybe microphone pickup is a different story, but this little circuit is adequate for what I'm doing, and it's pretty simple. So that's what I'm doing for the circuit. Now let me jump into what does some of this code look like to make a tone generator work. Now I will comment, you can go into the data sheet for the 265, and there's not a whole lot in the data sheet talking about how to use the tone generator. And what I've done in my code here is I just created a tone gen assembly file and put a few things that maybe you would get from the data sheet up here as far as some initial notes. So first things first, tone generator 0, it's on pin 94 of this package that I'm using. And again, I mentioned the speaker and this little transistor I'm using. You do need to enable the tone generator through the BCR, and I'll walk through that code. And also the tone generator uses a very specific timer 5, or T5 here. And so you need to set up basically a value in that timer, and that's going to control the frequency. So as you increase the timer, you're going to decrease the frequency that the speaker will output when you have it enabled. Something I did find helpful is the Mensch monitor. They've posted the source code for that, Western Design Center has, and there is a specific ASM file that talks about the tone generator, or uses the tone generator. So if you want to look at that, that's a nice little reference too. Let me jump into my main code. I will mention, this is just a side comment, I've split out my code. So I have this 265 primary. This is my primary board. Again, I'll have a secondary AV board at a later date. But in this, you're now going to see that I have a whole bunch of includes. So when I get down here, you'll see I'm including separate files. So I've taken all that functionality, I've pulled it out of this main assembly file, put it into separate, discrete files, and then I include that here. Now, in this code, I am including the tone gen, and so I have a whole bunch of procedures that I'll walk through here. But when my system starts up back in the primary, I will maybe point a couple things out before I do that. I am tracking a list of to-dos, so as I post this source code, you can look at, what do I know I need to be working on. So there's some stuff there, and this probably needs to be updated too, but that's kind of my reminder of things I need to do. I am also documenting the configuration, so this should match the current board I'm working on. And I am also capturing the memory map because there's quite a few pieces to it here, where I've got my different vias that I'm using. I have some external flash, a larger external flash, a larger external static RAM, the smaller external flash and static RAM, and then all of these other things that are just out of the box with the 265. But I have that memory map now captured in there, and some different notes in these note sections. But I am going to go down to, on my startup here, that's this code here, that I come down and I, first of all, configure the MCU. That's the same as it's been in previous videos and code. I haven't really been changing that. But now I'm into this play a tone, and I call play tone startup sequence. So when I first turn the system on, there's 3 quick beeps, and that is going to call this play tone startup. Then after that, I delay about a second, and then I do some initialization, more initialization, more initialization, more initialization, and I just kind of keep working through all that. And when I'm kind of done with all the initialization, I turn on interrupts, and I play a different tone to mark complete, and that is an escalating 3-tone that shows up on the piezoelectric. And then I wait a couple seconds just to put a delay in there so that you can hear the difference as I go from that to the next sequence that I play, then I delay, and then I play another sequence. So let me go over to Tone Gen and just show you what does it take to do this. Now, I was calling this play start up, this start here, and I'll show you how I've set this up. So I come in here and I'm going to do some testing, and I decided to go with the on a MIDI keyboard, going with the middle A key, which is often referred to as A4, and that should be a 440 hertz note. It's also MIDI note number 69. And I have set up EQs, so I have a bunch of those set up further down in this code that gives me a nice friendly label for every note that maps it to the MIDI note number. But ultimately, if I want to play a tone, I need to understand what is the timer value. You have to set the value in the timer, and you have to enable the timer, and you need to enable basically this, what I had mentioned way up top here, this BCR. So what I do here, I'm playing 3 notes. I'm playing the same note 3 times, but 3 very different ways. And so the first is I just know the timer value, and you can go to the data sheet, and the data sheet has a formula you can use on how do you calculate the timer value for a given frequency. So take a look at that in the data sheet. But basically, I know that if I want a 440 hertz note, which is this middle A or A4, that it should be this frequency, and this is a 16-bit value that I need to have. So I load up that value. Now keep in mind, I am in 16-bit for my my A register and my indexers like X and Y. And so I load up this value, and I also load into X a value 100. That's just how long do I want to play the tone. And then I call a procedure here that I have called TG0 play tone. And when it comes back after this delay, I then disable. So I need to play a tone, I need to disable, and I'm going to focus just on that for a minute. So I've loaded into the A register kind of what is the timer value, using the calculation, doing it manually. This is the value for 440 hertz. I then load up a 100 millisecond delay, and I say play that tone. Well, if I go look at that play tone, what I do inside of it is I store that timer value into T5CL. And so that's a register, and it's followed by the CH, the high. So there's a low byte and a high byte. I'm writing 16 bits or 2 bytes, so it ends up writing both to CL and CH. If you weren't in 16-bit, you'd want to write the low byte, and then you'd want to write the high byte. But that's basically setting my timer. I'm then going to go enable my tone generator. And to enable the tone generator, basically I have to enable the timer and enable the tone generator itself using this BCR. Now, to enable the timer, there is a timer enable register, and I've used this in other code I've showed up to this point, more for UART stuff. But basically there's a bit, it's this bit here, so that would be bit 5 of TER, so maybe people would call that TER5. I load that up, and then I test and store it. So basically I turn on that bit, and that basically enables the timer. And then I do the same thing with BCR. I turn on this bit 1, and bit 1 is for TG0. And so this is turning on my timer, it's turning on my TG0. But remember, before that I had set in the timer value so it knows kind of at what speed it's going to play this frequency. So that's my enable. And so when I come back down to the play tone, again I store the value in the timer. I then enable the timer, and I enable the tone generator. And at that point, it would be playing that tone, and I then delay, and this is the way I've written this function is it uses X to calculate the delay, which I had previously set when calling this. So X is the number of milliseconds. So when it's done with that delay, it will then jump back out of play tone over to my disable. Now my disable then comes in here and basically disables the tone generator and the timer. And so it's just, instead of setting that flag, it's resetting or setting it to 0. It's turning off this flag, it's turning off this flag of my BCR and my TER. Now, the BCR, TER, those all are defined in my EQs. So if I come in here, let me just search TER. Is right here. So there's my TER. It's at address DF43 for that register, and there's my BCR. So at this point, I've come in here and I've loaded manually. Here's the timer value, and then I say play that tone, and then turn it off, wait 50 milliseconds, and then I want to play the same tone again, but this time instead of having to know that timer value, I just want to give it a frequency. So I wrote a little routine that says get the timer value, which it should return this, from the given frequency of this. So all I have to do is load into my A register what frequency I want, make this call, and then that will give me in the A register the frequency basically converted to the timer value, and then I continue the same way. And so this little routine I have, if I scroll down here, basically does some math, and there's basically a 32-bit by 16-bit division that I have to do. You can read through this. This is not me inventing this from the ground up. This is finding some of this sample code out there. But basically, I'm just simply converting using the formula that I need to convert what they post in the data sheet. So I need to return in the A register a timer value, And basically it's this function. That's a simplified function, but what frequency am I asking for? This 625000 is based on me running a 10 megahertz clock. So if you're running a different Phi 2 clock, this is going to be a different number. Go look at the data sheet, page 35, for that calculation, and replace this number with your appropriate number. But then this goes through and does some math, and at the end of the day, into this procedure, it returns out the timer value for the given frequency. So that's the second way that I then play a tone. So the first one, I manually set the timer value. The second one, I just give it a frequency. But that's still a little not as friendly as the next way, where I can just tell it which note do I want to play. And so I have a bunch of EQs set up, and I preface them all with MIDI. So MIDI underscore A4 says I want to play the A4 note. So on a keyboard, it's that, whatever it is, fourth octave A. So I say I want to play that. And I can load up that, basically enum, that value. And then I have a procedure that says get the timer value. And instead of from frequency, I just say from MIDI. So I'm specifying this MIDI value, and then it's going to give me the timer. Now, if I go look at that procedure, basically I have a table of frequency. So there's this frequency table, and I'm going to go find whichever MIDI note you said you wanted, and then get back what the frequency is, and then I can convert the frequency to a timer. Now, I could shortcut that. This is just using this for reuse and simplicity, easy for me to mentally work through this. But if I look at that frequency table, a couple of things here. I've got a MIDI. Here's a table of all the MIDI notes. So I can say MIDI, whichever note, a C0, a C sharp, an E flat 0, and I know what MIDI number those are. And then I also can convert any MIDI number, like MIDI 0, to what is the frequency. And that's what this data is doing for me. So with those, that gives me this easy support here to say that if you just give me a MIDI number, I can then look it up, get the frequency, and then convert the frequency to a timer value. And that gives me this third setup that I'm doing right here. So I'm playing three notes, three identical notes. The first one I hold 100 milliseconds, and then I hold 50, and then I hold 50. So here I'll just replay that previous clip so you can hear just that piece again. Okay, so that was, this initial, when I turn on the system, play a startup, that's that kind of a long, short of the middle A. Then I get through all of this, and I have a very similar type of procedure, startup complete. I call that play tone. And if I look at that, startup complete, I'm playing it pretty simple here. Just load up a timer value, another timer value, another timer value, and play. So I have a play tone that enables everything and plays the tone. But then I have a switch tone. So I don't actually disable anything. I don't disable the timer. I don't disable the BCR or the tone generator. I just, while it's running, switch to a different value for the timer, which changes the frequency on the fly. And then I do it again. And that switch tone is pretty simple. All I'm doing is taking whatever's in A for the new timer value and just storing it. And that's it. And then I call it delay, which just holds that tone for that period. So this is going to hold the tone for 100 milliseconds. Then it's going to jump to a different frequency, hold it for 100 milliseconds, a different frequency, 100 milliseconds. And again, these basically values you put in the timer, the higher the value, the lower the frequency. So as I'm coming down in value, the frequency is going up. So I'm playing three notes, 100 milliseconds each, and those tones are moving up. And I just arbitrarily picked some values here. They don't really mean any specific note on a keyboard or anything. So here I'll play back that clip just so you can hear that. Okay, then after that, I then come in and I play a MIDI sequence. And so I thought if I actually want to play music or songs, why you would do it on a piezoelectric speaker, I'm not sure. But if you wanted to have some specific sequence, that meant something a little bit more than just me arbitrarily picking some tones, you can do that. So I've come in here and I've set up I'll jump down to this play MIDI. Let me get this one right here, play MIDI sequence. Now, first of all, this procedure is going to look for a very specific set of data that I have in song data. And so if I come down, I have song data, and this is a Mario theme song. And the way I've set this up is I can just put in the data that is what note, how long to play in milliseconds, next note, milliseconds, next note, milliseconds. And so it's just a sequence. That's all this is. So it's that much data to play that Mario theme song. And it's just a note delay, or note hold, I should say, note hold. If there's a rest, that means I want you to hold, but with no output. And there is also at the very end of this an end. So I can put in this MIDI end, and if that value is there, that's just marking the end of this, so that as it's looping through, it knows at what point do you stop. So I've got the data like that for my song data for Mario. And then when I want to play it, this is the code that goes through and does that. And basically, I'm going to index into that and say, okay, go out to the song data, load up the first piece. If it's all Fs, then I know that it's the end of the song. If it's not, keep on going. If it is, jump down to song done and get me out of here. If it's not the end of the song, then I check, is it a rest? If it is a rest, that means I don't want to play a note, but then I jump down to handle rest, where really what I'm going to do is just simply delay. And so I'm not going to do anything other than just simply delay. And I delay for whatever the value was stored in that data. Now, if it isn't an end and it's not a rest, then I go and I play it basically. So I have to go take the MIDI note, whatever was down in my data down here. Let's say this E5. And then I take the E5, I get the timer value, and basically I then need to also get the duration, which is the next piece of data. I put that into my X. So I've got my A for my timer value, I've got my X for how long, and then I just call that same procedure from earlier, a play tone. And at the end of it, I disable the tone generator. I guess one other thing in here, there is a move to next. So before jumping up to next note, I come down here and I do a really short pause just so notes don't slur together. But that's all that this is doing. And then again, there's my increments to get me to the next set of note data. And then I jump back up to here. So that's my play MIDI sequence. Now, instead of just hard coding that song data is what I want to use, I could probably have a variable that I first just simply write a pointer to what song I want to play and then call this. I started playing around with that, and I was having issues with that just because of which page I was in, and the indexing, long indexing wasn't playing nice with me. So I need to come back to that and see if I can get that figured out. But for now, I just created a second play sequence. Exact same thing, except for I'm pointing to a different set of song data. And that set of song data is this Monkey Island little tune. So exact same thing. It's just going through and saying, here's the note, here's the delay. And that's the end of that data and of that playing sequence. So I think those are the main chunks that I put in here. Let me real quick just repeat and replay the two songs, the two little MIDI sequences here, so you can hear those again. So in short, if you want to use the tone generator, you're going to use pin 94 or 95. If you're using the 100 pin package, you need to make sure that BCR bit 1, so not bit 0, but bit 1, the second bit, is used to enable the tone generator 0, or the following bit for tone generator 1. And then you need to set the timer values either on T5 or T6. In my case, I'm using tone generator 0, so that's BCR 1, and timer 5 that I need to be working with. And basically I set the timer value, I enable the timer, and then I enable the tone generator through the BCR. I might have delays in there to hold notes, and then ultimately then I turn around and disable the timer and the tone generator through the BCR. So that's the basics, and then it's just, you know, how much do you want to wrap it so it's easier to use, like I've done. Maybe here I can say, you know, play a specific MIDI sequence. I come over here and that sequence has, you know, a way to look up a bunch of tone data from down here along with the delays. And that all seems to work out pretty well. So that is intro to tone generators, I guess. And I do have my second board, the upper board, the AV board, en route to me. And when I do have that, that has a pair of programmable sound generators on it, which are far more capable than this tone generator. But this tone generator, for just simple things like what I'm doing here, post type beeps or, you know, error beeps, things like that, is going to be great. And then the programmable sound generators I'll use to do more of a gaming sound or other types of richer type of sound and music that I want to work with, or sound effects, things like that.